Okay, so good evening, everyone. I am Shomodip, and I am from the Department of Electrical Engineering at IISc Bangalore. I am doing my research here in the Department of Electrical Engineering at IISc Bangalore, and I am the TA for this course, Numerical Methods for Engineers, which is being handled by Professor Niket Kaisare in the NPTEL portal. So every week from Saturdays on 7 p.m. to 9 p.m. I'll be taking these sessions. So for total for 12 weeks for your 12 weeks of classes in the NPTEL portal, I'll be handling these sessions and you can ask your queries, any doubts pertaining to that particular week in this class. So 1 week class is completed, and in the last week we had discussed about the basics of numerical methods, the motivation behind the numerical methods, all those things. And okay, so today I'll start. And first, I will give a quick recap of what I had discussed in the last class, and then I'll quickly move on to the contents of today's class. Fine. My voice is clear, right? It's audible. Can someone confirm if the voice is clear and audible?
Yes, sir, it is clear.
Okay, fine. Okay, so last class I'll discuss what I had discussed in the last class. So basically, last class we had discussed about the importance of numerical methods, why we want to go for numerical methods, what is the difference between our normal analytical methods and our numerical methods, approximate solution we discussed. And then we went to what is the difference between exact solution and approximate solution. So we know there are two types of numbers in our number system, right? One is rational number and the other is irrational number. So rational number like 3 plus 3, if I ask you, you can exactly give the answer, right? It is equal to 6. However, what happens if I ask you the value of pi? So we'll say 3.14, right? It is not exactly 3.14 and it is an irrational number and it continues, the series continues. So we call that an approximate value or the value of exponential, that is e. It is, we say it to be 2.71, however it is 2.718 and it continues like that. And also square root of 2. So these are the type of numbers which are approximate solutions. So if I have an equation like x square equals 2. So if I ask you the value of x, that is square root of 2, you cannot exactly give me the solution, right? You'll give a rounded off or truncated solution. So that is the difference between the exact solution and the approximate solution. So now you might ask that why we want approximate solutions? Because any problems in our real day-to-day lives, those are basically all the equations involved are not linear. They will not get an equation in any problem. If you think in our engineering, it is not exact equation like x plus y equals to 2 and x minus y equal to 1, so that you can find out the values of x and y exactly. However, you will get some non-linear equations of which you have to find the solutions. So those equations will not always give you exact solutions. They will give you some approximate solutions, right? So that's why we need to understand how we can solve an equation. Suppose any kind of equation which does not give an exact value to a particular solution. So we need to iterate. That is, we will assume a particular solution and then we will use the iterative technique. That is, same thing will repeat again and again, and we'll see that the solution is converging to a particular value, which is not the exact solution to that equation, but is very close to the solution. One more example I'll give you, like we have these limits, right? All of us have learned limits in our class 11 and 12. So when we say limit x is tending to 0, what do we exactly mean? Do we mean that x is equal to 0? It's not x equals to 0. It is x is tending to 0 we are telling. So that is basically that value of x is very close to 0, but it is not exactly 0. So that is we don't have an exact defined value for x when we are saying limit x tends to 0. However, we have an approximate value of x which is very close to 0. So this is the difference between an exact number and an approximate solution. So then we moved on to So these were the contents of the last week. You can get the recorded lectures of the last week in the NPTEL portal. So you can go through it and you can come back to me if you have any doubts, those of you who have not attended the last session. So we discussed about introduction and motivation. Then we went to errors and approximations. Then we saw the truncation of a number and the rounding off of the numbers. Then we went to binary numbers and floating point numbers. Then we saw the different iterative methods. In that, we saw the Hennan's algorithm to find out the square root or cube root of any number. Then we saw the different sequential methods, and we also saw the direct methods in numerical techniques, right? So this all you can, I'll upload these notes in the, I have not uploaded the last week's notes. I'll upload it in the portal. You can just go through it and come back to me if you have any doubts. So we saw the Taylor series, Maclaurin series, all those things we had seen. And finally, we had seen how to convert a binary number to a floating point to a decimal number and a decimal number to a binary number. All these things we saw in the last class, right? So without any further delay, I'll start today's class. So the contents of today's class are, so first is we will see some basics of linear algebra. Then we will go to introduction to linear equations. Then we will see rank of a matrix and how to find solution of a linear equation from the rank of a matrix. Then we will see pivoting algorithm. Then we will move to then we will see Gauss elimination technique. And back substitution. Then we will see LU decomposition way of solving a matrix. Okay, so first I'll start off with basics of linear algebra or then the introduction to linear equations. So if you have any doubt, you can stop me in between and you can ask me your doubts or you can post in the chat section. Fine. Okay. So suppose I have two equations, right? Suppose I have two variable equations, x minus 2y equals to 1. And I have another equation which is 3x plus 2y equals to 11. So what is the, if I want a graphical interpretation of these two lines, what we will see. So we know a variable, an equation with two variables. Here we have two variables, right? X and y. This is x, one variable, and another variable is y. So, this, if I just plot in the xy plane, it will represent two lines, right? So can you just tell me, think and tell me why, like if I have an equation with two variables, why does it represent a line? What does these two variables represent actually? So these two variables, that is number of unknowns, it basically represents the dimension of the system. So here we have two unknowns. So this is a 2D system. That is, we will plot our equations in a 2D plane. That is, we'll have two axes, x and y. And in that we will plot, right? X and y. So now if I ask you to plot these equations, so x minus 2y equals to 1. How will you plot these equations in the in this 2D plane? So what we will do is, the first equation I have is x minus 2y equals to 1, right? So we know the general equation of a line, right? So if I write like this, x by a plus y by b equals to 1. So then this is any 2D equation. If I want to draw it, if I want to draw a graph, the easiest method, there are many methods. You can find out the slope, you can find out the x-intercept, y-intercept, then you can do. So directly if you do like this, any equation, if you represent in this form, x by a plus y by b equals to 1, we can plot that equation, right? So this equation, we have x minus 2y equals to 1. If we represent it in this form, what we will get? It is x by 1 plus y by minus 1 minus 1 by 2 equals to 1. This equation just I have rearranged and written it in the form of x by a plus y by b equals to 1. So this actually represents that the x-intercept is 1 and y-intercept is minus half. So how will the line look like? X-intercept is 1, right? So we have suppose 1 here and minus half is here. So this line will pass through these 2 points. So this is the plot of my line. I have drawn it with a dotted line. Okay. So this equation is x minus 2y equals to 1. And another equation is 3x plus 2y equals to 11. So can you write it in this form? X by a plus y by b equals to 1. What will be a and what will be b? Can someone just type in the chat section and respond? So it is, can someone tell what are the intercepts? Anyone?
X by 3 plus y by 2 is equal to 11.
X by 3 plus y by 2 equals to 11. How did you get it? It is 3x plus 2y equals to 11, right?
Yeah.
So right side we have to make it equal to 1. So if I want to make the right side equal to 1, by what should I divide? Isn't it this type of thing? We are dividing both sides by 11. So our aim is we have to make the equation in this form, x by a plus y by b equals to 1. So now we have 3x by 11, right? So we can write like this. Is this representation clear? Any doubts, anyone? Okay. So x by 11 by 3 plus y by 11 by 2 equals to 1. So this means that I have an x-intercept of 11 by 3 and y-intercept of 11 by 2, right? So I'll try to plot this here. So this point is 0 minus half and this is 1 comma 0. So similarly, I'll try to draw this. 11 by 3 means around 3, right? So around 4. So we will use some other color. So 1, 2, 3, 4 here. Approximately here we will get 11 by 3 comma 0. And we have 11 by 2 means 5. Approximately here we will get. So this line 3x plus 2y equals to 11 will pass through these 2 points, right? We'll just join these 2 points. So we have these 2 lines, right? So we have drawn this system in our 2D plane and we see that there is an intersection point, right? So this is the solution of these two equations. So what does the solution means? That you need to find a particular set of x and y which satisfies both equation 1 and equation 2. So just try to think it intuitively. So any point on this blue line will satisfy x minus 2y equals to 1, right? And any point on this yellow line will satisfy 3x plus 2y equals to 11. So I want a point x and y which satisfies both these equations. So that point should lie on both the lines, right? So there is only one point which lies on both the lines, which is this red point. So if you draw this exactly on a graph paper without solving this equation using our general technique, we can find the coordinates of these points. So can someone tell me what are the coordinates of this intersection point? Yes, just solve these equations and you can find the coordinates of these 2 points. What is the coordinate of these 2 points? Anyone? Yeah, correct. So it is 3 and 1, right? So this is known as the graphical way of solving the linear equations. So this was the most ancient technique or the first technique which was invented to solve any kind of linear equations. But what do you think can be the disadvantage of this type of solution? So the main disadvantage which was seen in solving the equations using this graphical method is that if you have larger number of unknowns, so two unknowns when you have, you can draw that equation, right? You can draw that in a graph paper because our system is 2D. On the piece of paper, we are drawing this. It is easy to interpret a 2D. But if you have three unknowns, X, Y, and Z, we'll see it next. So that is not a line, it is a plane. So then we will see we cannot draw that exactly on the graph paper because our system is 2D. We cannot draw that. So we need to have some other techniques which solves the higher dimension equations. Is it clear? The main drawback, this is the graphical method, right? Graphical method. It's clear? Shall I move to the next topic?
Yeah, it's clear.
Okay. Just stop me if you have any doubts, okay? So now we will move to higher dimension equations. So suppose you have three equations, x minus x plus 2y plus 3z equals to 6, 2x plus 5y plus 2z equals to 4, 6x minus 3y plus z equals to 2. Suppose you have these three equations and you are asked to find the solution. So in 3D, so if two lines intersect, it is a point, right? It gives rise to a point. So if two 3D equations intersect, so first of all, we need to understand what is a 3D equation. What does it represent? So a 2D equation basically represents a straight line. And a 3D equation, it represents a plane. Three D equations represent a plane. So it is difficult to visualize the plane in a 2D paper, but still I'll try to draw it. We'll see here what will happen if two planes intersect. So Z, Y, this dimension is X. You have X here. So now if I want to find X plus 2Y plus 3Z equal to 6, right? We want to draw this plane in this 3D surface, 3D system. X plus 2Y plus 3Z equal to 6. So as I told you, in a line we used to represent it by X by A plus Y by B plus Z by C equals to 1. So here what we will do is just the same thing. We'll try to represent it like this: X by A plus Y by B plus Z by C equal to 1. So can you tell me what will be the values of A, B, and C here? How can I represent this equation x plus 2y plus 3z equals to 6 in this form? X by A plus Y by B plus Z by C equals to 1. Yes, correct, Nasim. Others, are you able to follow or should I go slow? Is the pace of the class fine for everyone?
Yeah, it's perfect.
Others, can someone respond? Is the pace fine for you or should I go slow?
No, sir.
It's fine, right?
Yeah, sir.
Okay. So x by 6 plus y by 3 plus z by 2 is equal to 1. So this basically means that we will have in the x side we will move 6 units, in the y we will move 3 units, and z will move 2 units. So that will basically give me a plane, right? So 6 units in the, suppose here is 6, y we have 3, and z we have 2. So basically we will have a plane like this. So we'll have a plane like this. X is this is a plane. So now the next plane, if we try to draw, what is it? 2x plus 5y plus 2z equals to 4. 2x plus 5y plus 2z equals to 4. So it is basically x by 2 plus y by 0.8, z by 2 equals to 1. So we will get another plane from here. So it will be a bit difficult to draw in this 2D thing. Still, I'll try. X direction you have 2. So basically it will be here. Y you have 0.8 here, and Z you have, Z is same. Some kind of this thing. Just try to imagine. It is difficult to imagine here. This type of plane we will get. And this was the previous plane. So if these two planes intersect, what we will get? Suppose it is this line, right? This line, when two planes intersect, we will get a straight line, right? This is the point of intersection of the two planes. So this green plane is on the other side, right? It's not on this side. It's on the other side of the paper. So we will get one line. So now there is a third plane. So for this third plane, what I will do is also will try to represent 6x minus 3y plus z equals to 2. So it is basically x by 1 by 3 plus y by minus 2 by 3 plus z by 2 equals to 1. So I'll not draw it here. I'll draw another figure. This is z, y, and x. So you will have, this was the line of intersection of the this previous two planes, right? So here is the line. This is the line, and when it intersects with, I'm not drawing here, it will be difficult to draw here. So if there is another plane, suppose a plane is like this, right? You have a notebook. It is like this. If another plane intersects with it, suppose this is another plane, another notebook if I take, just a second. So suppose I have two planes. These are two planes, right? If I have, just imagine this thing. If I draw like this, we are getting two lines here, right? This is a straight line when two planes are intersecting. And now we are having a straight line. So now when this straight line intersects with a third plane, what we will get? It is basically a point. So the solution of these three equations is a unique point. If I solve, so just remember this thing. If you have three unknowns and two equations, x, y, and z are the unknowns, and you have two equations. So from that, what you will get? You will not get a unique point. You will get a straight line. Three equations, suppose a linear equation I'm telling, three equations, three unknowns, two equations. Suppose you didn't have this third equation. If I had only given you 1 and 2, it is not sufficient to get a unique solution of x, y, and z, correct? You can get a solution in terms, a straight line in terms of x, y, and z. So I'll show this to you. Suppose x plus 2y plus 3z, x plus 2y plus 3z equal to 6, 2x plus 5 and 2z equal to 4. So if I solve these two equations, what I will get? I'll get a straight line. I'll just solve these two equations and show for you. So that will be more convenient, I think. This is 1. So here from this, I will try to eliminate z. Okay. So if I try to eliminate z, multiply by 2, multiply by 3. So what we will get? You will get basically 2x plus the equations 2x plus 4y plus 6z equal to 12. And the second equation we multiplied by 3, right? 3x plus 15, 6x plus 15y plus 6z equal to 12. So now if I try to eliminate x and y, minus, right? So minus 4x minus 11y and z will cancel, equal to 0. So what we are basically getting? 4x plus 11y equal to 0. So this is a straight line, right? Just a second. This is a straight line. So I have shown you that when two planes intersect, we will get a straight line. So now I have the third equation. It is 6x minus 3y plus z equals to 2, right? So now if I solve these two equations, I will get a unique value of x, y, and z, which is a point. If I solve these two equations, suppose this is my third equation, fourth equation. This is 1, 2, this is 3. So if I solve these two equations, basically we have 6x minus 3y plus 2z equals to 2, sorry, plus z equals to 2, and 4x plus 11y equals to 0. So if I multiply this by 2 and this by 3, what I will get, I'll get 12x minus 6y plus 2z equals to 4. 12x plus 1133y equals to 0. Okay, so these equations I have taken randomly. I think there is no solution for these equations. So basically, this is the understanding thing. I'll get back. These equations I think doesn't have a solution, so that's why I'm not getting properly. So basically, when two planes intersect, we will get a straight line, and when a plane intersects with a straight line, we'll get a particular point. Yes, we can. Yes, Leonardo, we can use matrix method, but the equations I have chosen here randomly. So that is the reason why I'm not getting a exact solution for that. I'll come to the matrix method of solving the equations very soon. Okay. And as the number of unknowns increase, that is when there are two unknowns, we have a straight line, right? When there are three unknowns, that basically represents a plane or a surface. When we have four unknowns, what does it represent? It represents a 4D plane, which is an abstract concept. We cannot imagine that. So that concept is called a hyperplane. Just remember this term. When you have, suppose, you have n equations and n unknowns you have. So you will basically get nd surface or nd space, and you will have n minus 1d hyperplanes. So this concept of hyperplanes starts from three equations or four equations rather. We can where we cannot imagine. We have three equations, three unknowns. We have 2D hyperplanes, and if 2D plane, right? So a plane is basically in a 3 dimension, but we call it a 2D plane. When we have four equations, so to represent that, if we try to draw it, it is basically a 3D hyperplane. So this is the thing. This concept of hyperplanes, this is an abstract concept. Just remember this term. I think Sir has also explained in his lectures the concept of hyperplanes. So one more, just a small thing before I go to the matrix form of solving the equations. So you have a idea what is the difference between a surface and a plane? Anyone? Any idea on what is the difference between a surface and a plane? Okay, so before that, tell me what is the difference between a line and a line segment? So we often use these terms, right? Line segment. Then in 3D concept, we use surface, plane. So we need to understand what is the difference between these things. So in the common language, line and line segment might mean the same, but in the geometrical thing, it is not the same. So a line segment means a straight line which is bound. It cannot extend. It is represented. We had learned this in our childhood when we were introduced to geometry. We were told what is the difference between a line and a line segment. So this is a line segment, right? It is bound. The end coordinates are fixed here. Whereas a line, just a line, is free to extend. It is bound, and a line is free to extend in either directions. So it is free to extend. Fine? Is it clear? Similarly, this is the concept in 2D, right? Yes? You want to tell something, anyone?
No, it's clear. I understood.
Okay. This is 2D system. So when we go to the 3D system, we have a surface. So a surface means the end coordinates. That is, if you have a 3D surface, suppose a cuboid, so you will have six end points, right? So those are bound. A surface is bound. whereas a plane is analogous to a line which is free to extend. Clear? So just remember these two things, a line segment and a line. Yes, Leonardo, can you unmute and speak what you are trying to tell? It's not clear. Hello? You're telling line segment is a defined linear function in an interval. Yes, correct. That is what I'm saying. A line segment is bound, right? The interval of that particular function or whatever you're telling, that is fixed. Whereas a line is free to extend. There is no limit on the endpoints. Similarly, if we translate that to 3D, it is like a surface is bound and a plane is free to extend. Okay, so this was the introduction about the linear equations, the 2D and the 3D things. Now we will move to the matrix form of the equations. So in the matrix form of equations, we will see how to form a matrix form, what is the row picture and column picture of a matrix form of equation, and then we will see how to solve the equations using Gauss elimination and back substitution. So suppose we take the same equations what we were taking. So we have these two equations, right? So any equation can be represented in this form. Matrix A multiplied by the unknown matrix is equal to the right hand side matrix, or AX equal to B, we generally tell. Okay. And we form the augmented matrix also, which is like, okay, first we will see what is A and what is B. So what is matrix A here? It is basically 1, -2, 3, and 2. What is X here? X is the unknown. It is a column vector, X and Y. What is B? B is the right hand side matrix, right? 1 and 11. Okay. So now we have another term, which is known as the, which we will see very shortly, which is the augmented matrix. So what is augmented matrix? We write like this, A dash A slash B. So basically we will combine A and B here. 1, -2, 3, and 2, right? So then we'll put a dotted line here. Then we'll write 1 and 11. That is A and B together. Nothing very innovative thing. It just will represent like this. It is a way of representing which we will need in our solving the equations. Okay. So this is the augmented matrix. So now we will see what is called as row picture and column picture. Row picture and column picture. So in row picture, what we will do is we will take one row of the coefficient matrix. So this A is called the coefficient matrix, X is called the unknown matrix, B is called the RHS or the right hand side matrix, right? So what we will do, take one row at a time and multiply with the unknown variable or the unknown matrix. So it is basically A into X. So it will be basically row 1 into X and here row 2 into Y. What will be the row picture here? X and 3y. So this row picture is not much important. So what is important is we'll look into the column picture and graphically what it is trying to express. So what is the column picture? So column picture is basically X into column 1. There is the first unknown variable into the first column and Y into there is a second unknown variable into second column. So if we write it like this, X into 1, 3 for this equation plus Y into minus 2. This was the RHS matrix. So if we represent it like this, so what does it basically mean? Just it is a way of this column picture and row picture. It is a way of just simplifying our notation. That is what we are trying to understand what this X and Y are meaning actually. So we will try to draw it on a 3D plane, this thing, and we'll try to understand. So this is my 3D plane. This is X, Y, and Z. Right. So first we have a vector 1, 3. So we'll try to represent that 1 and 3 here. So X is 1 and Y is 3, right? Okay, so here 3D thing is not required. Sorry. So it is my 2D, normal 2D plane, right? X. You have in either directions. So suppose if you have X is 1 and Y is 3, right? So we'll move 1 unit in the X direction, 1 unit here, and 3 units in the Y direction, right? And we will get a vector. So suppose this is my 1 and 3. Then you have the second vector, which is minus 2, 2. So we'll move 2 units towards the X direction and 2 units towards the Y direction. So it will be approximately 1, 2, 3 here. So it is minus 2. And we have the right hand side matrix, which is 1 and 11, right? So we move 1 unit here and 11 units, suppose you get it here. One and 11. So now what it is trying to represent, just think it. So this X and Y, it is a set of values or the right set of coefficients, which when multiplied by these two vectors gives you the RHS vector. So if you can find out a coefficient, which when multiplied by 1 and 3, and then added with minus 2 and 2 gives you this RHS vector. So that is what is the value of X and Y here. So X and Y are the correct values of the coefficients which gives the RHS matrix. Is it clear? I hope it is clear. So you will see this, suppose if you have a vector 1, 3, if I just multiply it with a scalar, suppose 1, 3, if I just multiply it with a scalar, how will it look? Okay, so for this I need to tell you about the vector. Are you all familiar with the vector notation and drawing these vectors, vector operations? Everyone is familiar with that? So what happens when I multiply a vector with a scalar? So suppose this is X, this is Y. Suppose I have a vector here it is some say 2, 4. Okay. So if I multiply it with a scalar, say 3, then I will get 6 and 12, right? Just a second. Like this. 2, 2, suppose. Okay. So if I multiply it with a scalar, I will get just if I multiply it with 3, I'll get 6, 6. So 6 and 6 will also just multiplication by a scalar means just in the same direction, we'll have an extension to that. We'll get 6, 6 here. Okay. So this is the basic thing. So here, suppose 1 and 3, if I multiply by say, 1 second, what are the equations? X minus, okay, x is, if I multiply the first vector by 3, what I'll get? 3 and 9, right? If I try to draw what is 3 and 9, it will be in this same line because I'm just multiplying by a scalar. So now 3 and 9, and we have another vector minus 2 and 2. So if I multiply, if I just add these two vectors, see 3 and minus 2 is 1, 9 and 2 is 11. So we will get a vector 1 and 11. So we don't need to, we just, so here x is equal to 3 and y is equal to 1. Just from the graphical thing we can tell. So, so x and y are basically using this column picture, we can find out the correct set of coefficients which when multiplied to this individual columns of the matrix gives rise to the correct RHS matrix. So is this thing clear? Any doubts? Any doubts, anyone? Is it clear? Nasim, Leonardo, and Archana, everyone, it is clear?
Yes, sir.
Okay. Any confusions? If, anyone, you can ask me in between.
Yes.
Okay, just we'll take a 2 minutes break and then we'll start again.
Okay, sir.
Okay, so I'll start off. So now we have seen what is the importance of row picture and column picture while solving the equations in the matrix form. So now we will look into another example of column picture. So here it was in the 3D, right? So, okay, I'll just go through it. So in column picture, suppose in 3D, what will happen in 3D? Suppose you have three equations, x, the same equations I will take, x plus 2y plus 3z equal to 6. You have 2x plus 5y plus 2z equal to 4. 6x minus 3y plus z equal to 2. This is the first equation, second equation, third equation, right? So we'll try to draw these equations. First, I'll write the column picture, right? So what is the, if I write it in the form of column picture, so first I have to write the A and B matrix. What is A here? So it is 1, 2, 3, 2, 5, 2, 6 minus 3, 1. And B is 6, 4, 2. So here, if you write the column picture, it is, so it is x into 1, 2, 6 to 2, 5 minus 3 plus z into 3, 2, 1. So this is the column picture form of representation of these three equations, right? X, y, and z will multiply. So now if I just try to plot it in the graph, so it is a bit difficult to draw here. So if I suppose I'll not draw it here, I'll just, so suppose you have three vectors, right? This is say 1, 2, 6, 1, 2, 6. Then you have say this one as 2, 5, and minus 3. And you have this third vector z. uh, So z is basically 3, 2, 1. So now we have another vector which is 6, 4, 2. That is the RHS matrix. So see 6, 4, 2. If I just multiply 3, 2, 1 by 2, we will get 6, 4, 2, right? So I'll shorten this vector. So if I draw it like this, 3, 2, and 1. So now if I just how can I draw 6, 4, 2? 6, 4, 2 is just the in the direction of this 3, 2, 1 vector multiplied by 2, right? So if I just extend this vector, so this is my 6, 4, 2. So x and y here will be 0 and z is 2. So this is the correct combination of the coefficients to get the RHS matrix, which is 6, 4, and 2. So this column picture thing is clear. It is just an intuitive way of solving your any system of equations. It is basically a way of solving your this linear equations. So is this thing clear? Can I move forward? Fine with everyone? Yes, Leonardo, what you're telling? No, it's not hit and trial, man. It is not hit and trial. If you have a original graph paper and you draw these equations, if you draw these vectors actually, then you will obviously you will get to know what are the correct combinations so that I can get in this direction, so that I can get the resultant vector in these directions. It is not hit and trial. Any other doubts? It's fine. Okay. So I'll move to the next topic, which is Gauss elimination. So we'll see how to do Gauss elimination and back substitution to solve any equation. Okay, first we'll see Gauss elimination. Okay. Suppose you have three equations which are x plus 2y plus z equal to 8. The first equation. Then you have 2x plus 3y. Then you have 3x plus 7z equals to 34. So you have to find the value of x, y, and z. So the method is here Gauss elimination and then back substitution. So I'll do this problem, and through this I will explain you, because if I explain you the algorithm just, it will be difficult to understand. So what I'll do is I'll solve this problem and I'll explain you. So the first thing is you have to write what is a augmented B matrix. So it is basically 1, 2, 1. First write A here, 2, 3, 4, 3, 5, 7. Then we draw a line here, 8, 20, and 34. So this is my augmented matrix. So now, what is my aim here? So my aim here is I have to convert this matrix to an upper triangular matrix. You know what is an upper triangular matrix and a lower triangular matrix? So an upper triangular matrix is basically all elements below the principal diagonal will be 0. Suppose you have A11 here, A212 here, A13 here. Then you have 0 here, 0 here, 0 here. Here you have A22, A23, and here A3. So this is an upper triangular matrix. So this is my principal diagonal here. And all elements below this are 0. And all elements above this are non-zero. So this is an upper triangular matrix. Similarly, a lower triangular matrix is, the property of lower triangular matrix is that all elements below the lower this principal diagonal will be 0. And all elements on the principal diagonal will be 1. So this is 1, 1, and 1. So here you have L21, L31, L32, and all these are 0. So this is a lower triangular matrix and this is an upper triangular matrix. So in Gauss elimination, what we do is we convert this augmented matrix into an upper triangular matrix. This is the first step. So step 1 is convert to an upper triangular matrix. So we'll do that. What was our augmented matrix? 1, 2, 1, 8, 2, 3, 4, 20, 3, 5, 7. Okay. So I have to make these two elements as 0, right? This element I have to make 0. This element I have to make 0. And this element. So if I can make these three elements as 0, then my matrix will be an upper triangular matrix. So you know the row operations, right? So we operate on the rows and we make these elements as 0. So the first row operation is, this is R1, right? This is row 1, this is row 2, and this is row 3. So if I replace R2 by R2, so this 2 I have to make it 0. So R2 is R2 plus A21 into R1. And R3 is R3 plus A31 into R1. So now what is A21? A21 and A31 are the coefficients, right? A21 is basically minus A21 by A11. And A31 is basically minus A31 by A1. So if I find out what is A21 here, what is A21? Can someone tell from this matrix? Yes,
2. 2.
it's minus 2, right?
Yes, sir.
Minus 2. And A31 is minus 3.
Minus 3.
Yeah. So R2 is basically R2 minus 2R1, and R3 we will replace by R3 minus 3R1. So if we do these two operations here, so in the first step, my A slash B will be R1 is same, right? It is 1, 1, 2, 1, 8. So what will be R2 dash? It is R2 is R2 minus 2R1. So 2 minus 2 is 0. 3 minus 4 is minus 1. 4 minus 2 is 2. And 20 minus 16 is 4, right? And R3 is R3 minus 3R1. So 3 minus 3 is 0. 5 minus 6 minus 1. And 7 minus 3 is 4. And 34 minus 24 is 10. Is the first step clear to everyone?
Yes, sir.
Okay. So in the next step, what we will do, so our first object, our two elements, we have made it 0, right? So this element is 0, this element is 0. So now this element we have to make 0. Okay. So now what we do is R3, we replace by R3 minus, sorry, R3 plus A31 into R2. And what is A31 here? It is minus A32 by A22. Clear? So what is A32 here? Minus 1. So minus of minus 1, 1 by minus 1. So A32 is minus 1. So what we will do is R3 equal to R3 minus R2. Therefore, the new value of augmented matrix will be, first row will remain the same, 1, 2, 8, 0 minus 1, 2, 4. So this will get replaced, right? So R3 minus R2. So 0 minus, so we'll see here 1 second. 0 minus 0, 0, minus 1, minus 1, 0, 4 minus 2, 2, 10 minus 4, 6. So this is 0, 2, and 6. So it's fine. So now our objective is fulfilled here. All these three elements we have made 0. This is 0, this is 0, and this is 0. All these three elements are 0 now. So now our Gauss elimination process is done. So now we will do the back substitution. So what we do in back substitution now, just from the back side, we will try to substitute in the equations. So this is your augmented matrix now. So what we will do is, this is the only non-zero element in the third row. So what we will do is, so this row represents X, this row represents Y, and this row represents Z. So what we will do in back substitution is, so now my A matrix is like this, right? 1, 2, 1, 0, minus 1, 2, 0, 0, 2. And my unknown variable is xyz, xyz. And this is a dash I will write. And b dash is 8, 4, and 6. So now if I replace this a dash x equal to b dash, what you will get? So it is basically 1, 2, 1, 0, minus 1, 2, 0, 0, 2, xyz equal to 8, 4, 6. So if I multiply this, I'll get x my plus 2y plus z equal to 8. Then we will get minus y plus 2z equal to 2. Sorry, 4. And next last equation we will get 2z equal to 6. So we will now proceed in the backward direction. First we will take the third equation, backward substitution. So if I take the third equation first, it is 2z equal to 6. So from this we will get z equal to 3. So now using this z equal to 3 we will move up. So the equation is minus y plus 2z equal to 4. So it is minus y plus 6 equal to 4 and y equals to 2. Then we will move to the third equation with these two values of x, y, and z. X plus 2y plus z equal to 8. If I substitute x plus 4 plus 3 equal to 8, x equal to 1. So in this way, we can solve the x is 1, y is 2, z is 3. So in this way, we can solve the equations. Is it clear?
Yeah, it's clear.
Yes, sir. It's clear.
Okay. Okay, so this is the process of Gauss elimination and your this thing back substitution. Okay. So now we will move to the next topic, which is LU decomposition.
Sir, in the Gauss elimination, can we take the decimal also, right?
Yes, decimal means, can you clarify it?
In the week 2 assignment, like they are given 5 x plus 3.8y minus 1.8 z is equal to 0.
Yes, that is the
Equation.
coefficients. The coefficients can be anything. It can be in fraction or it can be a whole number, anything. You have to follow this procedure.
Yes, sir. This is
First,
the method.
uh, first we will find out what is A and B. We'll write the augmented matrix A slash B. From that, we will convert that A slash B into an upper triangular matrix using your row operations. Correct?
Yes.
So
Yeah.
from that we will back substitute and we'll find out the values of x, y, and z.
Yes, sir. Row operations is like it depends on the numbers, right, sir?
Yes, it depends on the numbers. So this is the general formula. First step will be you have to make these three encircle numbers to be 0, right?
0.
So
Yes, sir.
R2 will replace by R2 plus A21 R1. R3 is R3 plus A31 R1.
Yes.
A21 is your minus A21 by A11. A31 is minus A31 by A11.
Okay, sir.
Minus 2, minus 3, then we'll replace these things. And in the next
Yes.
step, we have to make this second term to be 0. So we will replace R3 is R3 plus A31 into R2. Just keep in mind that this R2 is the updated R2. That is after the first step, this is my R2,
Yeah.
not the previous one.
Yeah.
So you have to
Yes.
keep
Yes.
that in mind.
Yes. Sir. Thank you.
There is a two-step procedure. So then we will get and then we'll back substitute and we'll find out the values of x, y, and z.
Yes.
Okay. So next we will move to LU decomposition. Okay. So first we will see what is L and U. L is as I told you, L is your lower triangular matrix. So the form of L is all elements in the principal diagonal will be 1, and all elements above the principal diagonal will be 0. All elements below the principal diagonal will be non-zero. So this is your and U is basically U is your all elements above the principal diagonal will be 0, right? So this is A11, A12, A13, 0, 0, 0, A33, 2, 2, 3. This is your upper triangular matrix. So what we do here, our form of equation is AX equal to B, right? So A is our coefficient matrix. So this A we will decompose into L and Q such that A is equal to L into U. So we have LUX equal to B. So then what we will do is we will replace this UX by another variable which is Y. So Ly equal to B. Okay. So you have this equation Ux equal to Y. We know U, we know Y. So we can find out X from here. Find X. From here you can find X. So once we find X, we will substitute this. Just a second. Okay. Just a second. Sorry. Okay. So first from this equation, we know L, we know B, right? So from that we will find what is Y. Using this Y, we will substitute here in the second equation. We know what is U, what is Y. We can find out X. So this is the algorithm. So now we will see how we can do this using the LU decomposition. So it is a bit lengthy method. I'll do these equations. Okay. I'll show you how to do. So suppose I'll take the same matrix. Okay. X plus 2y plus 3z equals to 6. 2x plus 5y plus 2z equal to 4. 6x minus 3y plus z equals to 2. 1. So first I will see what is my coefficient matrix. What is A? A is basically 1, 2, 3, 2, 5, 2, 6 minus 3, 1. So here we have to decompose this A matrix into its equivalent L and U such that L and U multiplied will give me A. Okay. So the process of finding U, that is the upper triangular matrix, is as I described in the this Gauss elimination. Find U using Gauss elimination. Find U using Gauss elimination technique, right? So that same process, you have to make these three elements as 0, right? Just a second. Sorry, the equations are written incorrect. So the equation, sorry for the thing, x plus 2y plus z equal to 8. Y plus 4z equal to 20 and 3x plus 5y plus 7z equal to 30. So from this, I write the value of A is 1, 2, 1, 2, 3, 4, 3, 5, 7. Okay. So now we'll convert this into upper triangular matrix like we did here. These three variables you have to make 0. So first step is R2 we will replace by R2 plus A21 R1 and R3 equal to R3 plus A31 R1. And okay, so A21 is minus A21 minus 8. Sorry, this is the 1 second. This is better to be represented by alpha, okay, because these are the coefficients alpha 21 and alpha 31, where this alpha 21 equal to minus A21 by A11, alpha 31 minus A31 by A1. So this we will get as minus 2, this we will get as minus 3. So A dash after the first step we will get 1 2 1 0 minus 1 2. So 0 minus 1 4 we'll get A. So next objective is this one, we have to make it 0, right? So this we will replace by R3 equal to R3 plus A32 R2, and A32 is minus, sorry again, it is alpha 32 is equal to minus A32 by A22. So it is basically minus 1 here. So A dash will be now A double dash after the second step. 1 2, the same thing which I did in the next previous problem. This is the same thing. So now this is a upper triangular matrix. So this is my upper triangular matrix U. So now I have to find the lower triangular matrix, right? L. So what is L basically? L, as I told you, it is, these values are 1. This is 0 0 0, and this one is basically the coefficients, that is alpha 21, alpha 31, and alpha 32. So here it is 1 0 0. What was A21 minus 2 1 0. A31 was, I think, minus 3, right? Minus 3. Minus 3. This one is minus 1. So you have got L and U. You can just verify. If you multiply this L and U, you will get the original A matrix. Okay. So this is the procedure for obtaining the L and U matrix. Is this process clear? Matrix into the lower triangular and the upper triangular matrix. Is it clear?
Yes, it is clear.
Okay, so we have got L and U. So now we will substitute. So we had basically AX equal to B, right? We replace A as LU. So it is LUX equal to B. So now what we told, we'll replace UX equal to Y. So LY equal to B. So from this, L we know, right? What is L? 1 0 0 minus 2 1 0 minus 3 minus 1 0 into Y. So I write it Y1, Y2, Y3 equal to your B. What is your B? B is basically 8, 20, and 34. So if I just solve this and find out what is Y, so Y is basically, so one thing here we have this lower triangular matrix property we can use. So in upper triangular, we were doing back substitution. That is, we were going in this direction. That is in the from bottom to top. But here we will go in the opposite thing. We'll go from top to bottom. So what is the first thing? 1 0 0. So we will get Y1 equal to 8. Then we will get minus 2Y1 plus Y2 equal to 20. So what is Y2 from here? 20 plus 16, right? So it is 36. Just a second. Some mistake I have done. Sorry. This is not 1. This is not 0. This is 1, right? This is 1. So the third equation we will get minus 3y minus 3x minus y plus z equal to 34. Sorry. Minus 3y1 minus y2 minus plus y3 equal to 34. Am I writing it correctly? Minus 3y1 minus y2 minus y3 plus y3 equals to 34, and y1, y2 in 8 and 36. Minus 24 minus 36. Y3 minus 60, 34. I'm not sure of the calculations I'm doing. So Y matrix we have got, right? What is Y? 8, 36 and 8, 36 and 94. Just check the calculations once. Is it fine? Just check it once again. 100 minus 2 minus 7, 8 and plus y2 equal to 20 minus 2 1 y1 is minus 16 plus y2 is 6 minus 3 minus 3y1 minus y2 plus y3 equal to 34 minus 24 minus 30 y2 is 36 60. Yeah, it is fine. So now we have got y, right? So what was our y? It was ux, right? Ux equal to y. So now we will substitute u. What was u? 1 2 1 0 minus 1 2. 1 2 1 0 minus 1 2. Then we had 0 0 2 0 0 2 x. X we want, right? X, y, and z equals to 8, 36, and 19. Some calculation mistake I have done, I think. Okay. Are the calculations fine? Can someone check once the calculations? I think this L thing is not correct. Just a second, I'll just check with L. Just 2 minutes to give me, I'll figure it out. One, 0 0 2 1 0 3. Hmm. 1 0 0. Just check here. If I have a equal to, I think some sign mistake I have done. L is basically 1 1 1 0 0 minus 2 minus 3 minus 1 0. And U is basically 1 2 1 0 minus 1 2 0 0 2. We just multiply these two L into U. So can someone multiply these two matrix and check whether it is giving this A matrix? Okay, understood. So this will not be the negative things. So make it 2 into 1, 2, 2, 4 minus 1, 3. Understood. So this is the problem. So here when you write this L matrix, no, this L matrix, so it is the negative of the coefficient we have to take. Minus alpha 2, 1, minus alpha 3, 1, and minus alpha 3, 2. So then you will get 2, 3, 1. Here 2, 3, 1. That's why there is a problem. So it is 2y1 plus y2 equal to 20. y1 equal to 20 minus 16, 2. y2 is 20 minus 16, 4. y2, 2. And here I had this doubt that why I'm getting so big answers. y1, y2, y3. 3y1 plus y2 plus y3 so 30 equals to 34. 3y1 is 8 and 2, right? 24 plus 2 plus y3. So y3 is 8. So y matrix is 8, 2, and 8. Is it 8, 2, 8? y2 is how much? 2. y1 plus y2 is 4, not 2. So it is 4. Oh, it is correct. y3 is 6. 8, 4, and 6. So here when you substitute 8, 4, and 6. So now you have ux equal to y. So from that we can say 2z equal to 6. That is back substitution again. Z equal to 3 minus 2z equal to 6 and minus y plus 2z equal to 4. 6y equal to 2 and x plus 2y plus z equal to 8. From that we have x equal to 1. Okay, so is it fine? Clear the process? It is a bit lengthy process and you have to do the calculations correctly. Is the process clear to everyone?
Yeah, it's clear. It's understood.
Sir, can you please explain how to write L and U matrix? That's it, sir.
Yeah, sure. I'll go through
Yes.
it once again.
Yes.
So what we do is you have the equations in the form of Ax equals to B, right? So we decompose this A matrix into L and U. So in the theory, in the matrix theory, it is told that any matrix can be decomposed into as a product of a lower triangular matrix and an upper triangular matrix. That is L and U. So there is a process for finding out the L and U matrix corresponding to a coefficient matrix. So we are doing this, finding this L and U, right? So to find U, I already described in the previous step, Gauss elimination. So using Gauss elimination technique, we find out U. So what we do in Gauss elimination, we basically do the row operations and make that 2, 1, 3, 1, and 3, 2 elements as 0. So for that, when we do that Gauss elimination, I told you these coefficients, right? Alpha 2, 1, alpha 3, 1. And in the next step, you have this alpha 3, 2. So these three coefficients will form your lower triangular matrix. So doing this, you get this upper triangular matrix, right? Doing the Gauss elimination, like the previous Gauss elimination technique I described. So now how you form the lower triangular matrix? So the lower triangular matrix is basically the principal diagonal elements are 1. Above that principal diagonal, all that elements are 0. And below that, these are non-zero. So this is minus alpha 2, 1. This is minus alpha 3, 1. And this is minus alpha 3, 2. These coefficients you get to know from the Gauss elimination in the previous step. So just substitute those coefficient values and you will get your L matrix. Once you get L matrix, you substitute that in that AX equal to B, A as L into U. Then you take UX equal to Y. From that, you will get Ly equals to B. So once you get Ly equals to B, this is the system of equations. That is 1, 0, 0, 2, 1, 0, 3, 1, 1, y1, y2, y3 is 8, 20, and 34. So do front substitution from the top to bottom. So you will get y1, y2, and y3. So your Y matrix is formed. So now go back and substitute it there. Ux equals to Y. You know upper triangular matrix. X is the unknown matrix, X, Y, and Z. And the right hand side matrix is unchanged, which is 8, 4, and 6. That is Y. So now you do back substitution again from the bottom. Whenever you have an upper triangular matrix, you have to do back substitution. And whenever you have a lower triangular matrix in your system, you will do front substitution. So from that, you will get X, Y, and Z. Is it clear, Archana?
Yes, sir.
Okay, fine. It's clear, right?
Yes, sir.
Okay. Now we will move to the last topic of today. Just 15 more minutes, 10, 15 minutes I'll take. So it is finding the rank of a matrix, right? How can you find the rank of a matrix, and using that, how you can solve your system of linear equation? Rank method. The rank method for solving the linear equations. So I'll first jot down the steps involved, then I will do a problem. Step 1 is you write the equation. That is in everything where we do that. Write the equation in AX equal to B form. Step 2 is write augmented matrix A slash B. Third step is convert this augmented matrix to upper triangular matrix using Gauss elimination. So your Gauss elimination forms the basis of all the methods. Once you know Gauss elimination very accurately, you can do all these methods. So we convert A slash B to upper triangular matrix. Using Gauss elimination. In the fourth step, we find out the number of non-zero rows in the augmented matrix. So this number of non-zero rows in this augmented matrix after converting it into upper triangular matrix is equal to the rank of the matrix. Okay. So here, once you get the rank of the matrix, you have three kinds of solutions, right? So the first one is if you have a unique solution. So if you have a unique solution for a system of equations to have a unique solution, the rank of A and rank of augmented matrix both should be equal to n, that is the number of unknowns. So you can have some system of equations doesn't have any solution. So that is possible when if the rank of A is less than the rank of A slash B, and the rank of A slash B is n. And you can have infinite solutions to a system of equations if both the ranks are equal is equal to rank of A slash B, but it is not equal to the number of unknowns, that is, it is less than n. So these things you have to remember, and then you have to use the solution. So this each case I'll do one. I'll take one problem each in these three cases. So three problems total, and I'll show you how to find the rank of a matrix, and from that how to determine the solution. Okay. So number one is unique solution. So you have, suppose the equations are like this: x minus 2y plus 2z equals to 2, 2x plus y plus 4z equals to 7, 4x minus y minus y plus z equal to. Okay. So these are your system of equations. So first I'll form the augmented matrix. It is 1 minus 2, 2, 2, 2, 1, 4, 7, 4 minus 1, 1. And so now using Gauss elimination, we will convert this matrix into upper triangular matrix. So first step is, can you also everyone parallelly do, then it will be easier to understand. So R2 is basically R2 minus plus alpha 2 1 R1. So it is R2 minus 2 R1. Directly I'm writing, I'm not doing it anymore. R3 minus 4 R1, right? So now you will get the matrix as 1 minus 2, 2, 2, 2 minus 2, 0, 1 minus 2 minus 5, 4 minus 4 is 0, 7 minus 4 is 3, 4 minus 4, 0, minus 1, minus 4 into minus 2. 1 second. Sorry, it is 1, 1 minus 1, 2. So it is basically 3 here. 1 plus 2 is 3, 4 minus 4 is 0, 7 minus 4, 3. And this one is 4 minus 4, 0, minus 1 minus 1 to minus 1 is 3, 1 minus 8 is minus 7, 4 minus 8 is minus. This is after the first step, right? So now this element we have to make 0. So R3 will be equal to R3 minus R3. So then we will get 1 minus 2, 2, 0, 3, 0, 3, 0 minus 0, 0, 3 minus 3, 0, minus 7, minus 7. Fine. So you can see from here, we have converted this augmented matrix into the upper triangular matrix. So this is my A matrix, right? This is my A matrix, and this total thing is my A slash B matrix. So this is my A matrix, and the total thing is A slash B matrix. So you can see the number of non-zero rows in A is equal to 3, and the number of non-zero rows in A slash B is also equal to 3, which is equal to the number of unknowns. So that comes under the first category here. That is, rank of A is equal to rank of A slash B equal to 3. So from here we can say that rank of A equal to 3. Also, your rank of A slash B equal to 3. Therefore, we have a unique solution. Right? We will get if I solve this, we will get a unique solution of X, Y, and Z. Is it clear, the first case? Clear for both of you? Or should I repeat?
Yeah. Yes, it's clear.
Archana, it's clear?
Yes, sir.
Okay, fine. So now you know how to find the rank of the matrices. Okay. Now we will go to the second case. So we'll go to the second case where we have no solution. Okay. So here we will see, we'll take three equations here, 2x plus 2y. I have taken three, I prepared these problems for you. X minus y plus z equals to 1. 3x plus y plus 2z equal to 4. So from here, we form this A slash B matrix. 2, 2, 1, 1 minus 1, 1, 3, 1, 2. Here we have 5, 1, 4. So what will be R2? R2 is R2 minus, it is basically 1 by 2 R1. And R3 equal to R3 minus, this one you have to make it 0, right? So it is 3 by 2. It's 3 by 2. A slash B will be now equal to 2, 2, 1. 1 minus half into 2 is 0. Minus 1 minus 1 is minus 2. 1 minus half is 1 by 2. 1 minus 5 by 2 is minus 3 by 2. 3 minus 3 by 2 into 2 is 0. 1 minus 3 by 2 minus 2. And here you have 2 minus 3 by 2 is half. And 4 minus 15 by 2. That is minus 7 by 2. Now this one we have to make it 0, right? So it is R3 equal to R3 minus R2. So what we will get? 2, 2, 1, 0 minus 2 half. So if I just subtract this 0, 0, 0, and you have 5, 3 by 2 minus 3 by 2 minus 7. So now you can see here that this row of the matrix A is completely 0. This is a 0 row, right? So A has basically two non-zero rows. So what is the rank of A? Can someone tell what is the rank of A here? What is the rank of matrix A? So the number of non-zero rows in A is 2. So the rank of A here is 2, right? The rank of matrix A is 2. However, what you are telling, Leonardo, can you please, are you listening to the classes or you're just randomly you're telling something? You listen to the classes and then answer to the questions, okay? You're not responding also, you're just typing something. So rank of A is 2 here. But if you see this A slash B total matrix, there is no non-zero rows because this row is non-zero. So all the rows are non-zero here. So the rank of A slash B is 3. So it falls in the second category, right? Rank of A is less than rank of A slash B. So this gives me no solution. That is, these equations does not have any solution. So these three set of equations, if you solve them also, you will see that there is no solution for these equations. Okay. So the last case we will do. Leonardo, can you clarify what you meant by 2 factorial equals to 3? It's better if you can unmute yourself and speak up. Okay, fine. We'll move to the case 3. So here you have 3x plus y plus z equals to 2. Then you have we have 7x minus y plus 4z equals to 5. So if I form the augmented matrix here, 3, 1, 1, 1 minus 3, 2, 7 minus 1, 4, 2, 1, 5. Which question you are telling? Oh, 2 not equals to 3. So here we will represent R2 equal to R2 minus 1 by 3 R1, R3 equal to, I'm going a bit faster because these are the same thing I'm doing again and again, right? So R3 is equal to 7 by 3 into R1. So if I find out what is this one, 3, 1, 1, 0 minus 3 minus 1 by 3 is minus 10 by 3, 5 by 3, 1 minus 2 by 3 is 1 by 3. 7, this is 0, minus 1 minus 7 by 3 is minus 10 by 3, 4 minus 7 by 3 is 5 by 3, 5 minus 14 by 3 is 1 by 3. So this one we have to make it 0 now, minus 10 by 3, we have to just do R3 equal to R3 minus R3. So you will basically get P112 minus 10 by 3, 5 by 3, 1 by 3, and this one you will have totally 0. All elements are 0. So what is rank of A here? Rank of A, there is one non-zero row and one zero row and two non-zero rows. So we have rank of A equal to 2, and also rank of A slash B is also equal to 2 because this entire row is 0, right? Both for A as well as for A slash B, both are zeros. So it is 2. So we have infinite number of solutions. I'll show you how it has infinite number of solutions. So if you just substitute, so you have the first row, if you replace, it is 3x plus y plus z equals to 2. And this one is minus 10y by 3 plus 5z by 3 equal to 1 by 3. So if you just take, so there will be infinite solutions, right? So let me assume z is equal to k. So this from this second equation, if I this one we will have minus 10y plus 5z equal to 1. So 5k minus 10z equal to 1. K equal to what is k? 10z plus 1 by 5. Sorry. Y we have to find out, right? 5k minus 10y. So 10y equal to 5k minus 1. So y is my 5k minus 1 by 10. And if I substitute here 3x plus y plus z equal to 2. So it is 3x plus 5k minus 1 by 10 plus k equal to 2. So 3x equal to 2 minus 5k minus 1 by 10 minus k. If I just simplify it, 20 minus 5k plus 1 plus 10k. So we'll get x equal to 5k, 10k minus 5k plus 21 by 10. So you have x is equal to 5k plus 21 by 10, y equal to 5k minus 1 by 10, and z equals to k. So if I substitute k as anything, we can take k 1, 2, 3, 1.5, 2.5. So we'll get the sets of values of x, y, and z. So there are infinite number of solutions because here we are having this x and y are dependent on a constant value k. That is the value of z here. So that's why we are having infinite number of solutions here. So if you plot these equations also, you will see that there will be infinite number of solutions because if you just these three cases, next class I'll show you also in your free time, you just try to plot these equations and see. So the first case you will see the three lines, the three planes if you see rather. So you will see they're intersecting at a point. The second thing, it is not intersecting at any point. So then there is no solution. And in the third case, you will see that it is intersecting at infinite number of points. So that's why we are having this infinite number of solutions. So this is all for today. We'll meet again in the next class. Any doubts, any questions regarding the assignments, anything? You can just tell me.
Sir, in the week 2 assignment, we have a like application problems.
Okay. No, this assignments, once the due date is over, then only I can solve. Before that, related to what, can you tell me? I can help you.
Yes, sir. Yeah, that one I can't solve properly, sir.
It
Application.
is related to what? This Gauss elimination, all these things, or something different?
Yes, sir. Yes, sir. To solve the above Gauss elimination or any other method.
So it is solving a linear equation only or something else? I have not seen the assignment.
Sir, it's like a application problem. They have given the 3 statements. According to that 3 statement, we have to build a matrix
Okay,
A and
okay,
matrix
okay.
B.
So
Yes, sir.
based on that, just okay, I have seen, I think that Sachin, Virat, and Rahul, that question,
Yeah,
right?
yeah. Yes, sir. Yes, sir.
Okay, you form those 3 statements are given, right? You
Yes, sir.
take the runs code by Sachin as S, Virat as V, and Rahul as R. Then from those
R.
statements, you try to form the relation between SV, 3 relations, 3 equations like this you will get. X in
Yes,
terms
sir.
of S, V, and R, right?
Yes, sir.
So from that, you try to solve. Just try to understand the English, what is being told there. So from that, you can easily form. If you can't,
Okay.
I'll solve it in the next class. Okay.
Yeah, sir.
Okay. Anyone else?
Thank
Any doubt? Nasim, anything? Any doubts?
No, sir. Today's class was clear completely.
Okay. Anything related to the course? You can, if you face any problem, you can just tell me. Okay.
Okay, okay, sure, sir.
Leonardo, everything is fine. Okay.
Sir,
Okay then. Yeah.
assignment problems you will solve after the due date, sir.
Yes. Yes. After the due date, I'll solve it.
Okay, 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 sir.
Okay. So when is the due date for this second assignment?
7th, sir.
7th. Okay. Then next class, definitely I'll solve the problems. Okay.
Okay, okay. First week and second week we have a same due date, sir. 7th, 8th.
Okay. 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 Fine.
7th.
Then
Okay.
once it is over, just remind me. I'll solve it in the next class.
Okay, okay, sir. Thank you, sir.
Okay. Okay. Fine. Okay. Then bye. We'll meet in the next class. Okay.
Thank you, sir. Thank you.
Thank you.